Hey science, I'm just gonna hop on here and make a really quick video because I feel like it might help for you to actually watch and be able to pause how I answer these questions and see kind of my method of how I answer them. So when I'm gonna label these, I'm just gonna go in and label them as V1, 2, and 3. Load 1, load 2, load 3. I just picked any load number. It doesn't matter which one you pick. It's completely up to you. I picked it from the positive in this situation because I was like, okay, I know current flows that way. You could have gone this way because electrons flow this way. It's completely up to you how you decide to go about it. All right. So I have the 6-volt battery and they are connected in series. So when I go back and I remember my equations, I know that voltage in a series circuit is equal to V1 plus V2 plus V3. And I know that the total current is equal to, is consistent across. So it stays the same, right? So let's go in and do our current first because I know current stays the same. So I know the current here is 10 amps, which means that the current here needs to be 10 amps, which means that the current here needs to be 10 amps, which means that the current here needs to be 10 amps. So my current across the board is going to be 10, 10, and 10. And I know this because I total is equal to 10. Therefore, I total is equal to I1, I2, I3. Right, so 10 is equal to I1, I2, and I3. Easy peasy, easy peasy. Now, let's move on to the more complicated one, voltage. And I'm going to do voltage in green. Right, so I know that voltage total is equal to the voltage at 1 plus the voltage at 2 plus the voltage at 3. Right? So let's go find out what I already have. The voltage at 1 says it's 1 volt. The voltage at 2, I don't know. So that one's a question mark. So I'm just going to write in my V1 and my V2. Right? So I don't know what this is. So that's a question mark. And V3, I was told it was 2 volts. So let's just go put in what I have. 6 volts is equal to 1 plus question mark or X or whatever you want to put in plus 2. Right, 6 minus 1, because I'm bringing this over to the other side, minus 2 is equal to question mark. So 6 minus 1 minus 2 is the same as saying 6 minus 3. So I'm left with 3 volts equals question mark. So I can just go back in here and change this to 3 volts. And that is how I would solve a problem like that. Okay? Alrighty. So moving onwards. Now, as we go into our next circuit, we're going to go, okay, let's just go in and label our loads. It's actually already labeled for us. So this says 1, this says 2, this says 3. I'm going to go in and say, what do I already know? I know that there is 9-volt battery, right? I know that the entire total current throughout this is 27, right? I'm going to go back and I'm going to go and be like, okay, I remember this is, what type of a circuit is this? I know it's a parallel circuit. And then I'm going to say, okay, from that, I remember that my I total in a parallel circuit is equal to I1 plus I2 plus I3, right? Then I remember that my voltage is equal to V1, which is also equal to V2, which is also equal to V3. This just means that when my current is traveling or when my electrons leave the pathways here, they come down, they leave, some of them split off and they migrate this way, some of them continue and they split off and migrate this way, and then like this. They're all split into 3 different paths, right? My voltage, which means that the amount of energy each of those has, is the same. So it's like if we were to leave class, right? And I said, all right, we need to move these 3 loads. Instead of all of us picking up and moving those 3 loads, if we had 3 separate teams that went down 3 separate hallways and picked up each of the loads individually, they would put their all or nothing. So when these electrons go past this load, they give them their everything. So They're giving them all the energy they had to start with. So my voltage is going to stay the same. It's going to be 9 volts, 9 volts, and 9 volts, because they're giving them all their energy. The amount of electrons splits up. So as I go down here, some of them are going to split up and they're going to go this way. Some of them are going to split up and they're going to go this way. Some of them are going to split up and they're going to go this way. So if I have 27 electrons, 27 amps, right? So if I had 27 students leave the classroom and some of you split off, say we all split off evenly, we would do 27 divided by the 3 different pathways that we could take. So 27 divided by 3 is 9 amps. Another way I could do this is I could say, all right, I know that IT is equal to I1 plus I2 plus I3, right? Since I don't have any of them, I'm just going to assume that they're all the same. So I'm going to say IT is equal to 3 times I1, right? So then I can just do 9 equals 3 times whatever I1 is. I1, divide that by 3, divide that by 3. And then I have, oops, it's not 9, it's 27. 27 divided by 3, and then 9 is I1, which is also I2, which is also I3, because they're all the same. Okay? And that's if I tell you they all split evenly. Alrighty. So, those are pretty easy. Let's go on to a little bit of a harder one. So if I have this over here, right, and I have this pathway ready to go, right, and I say I have a few things. I have this ammeter here, which is going to measure the current, which is at 3. I have this load here, which is 1, and an ammeter that's just going to measure the current at load 1. I also have a voltmeter at load 1 ready there to measure its current. Then I have load 2 over here, and then I have load 3 over here, also attached to an ammeter at the end of that circuit, and a voltmeter at the beginning of the circuit. So I want to find out what is the reading at the different ammeters. So ammeter 1, ammeter 2, ammeter 3, and what is the voltage at the different voltmeters. So now I'm looking at the different voltage at the different voltmeters that I have. Okay? So, first things first, I know right off the bat that my total voltage is 20. My total voltage is 20 volts. Is this a series or parallel, or a series and a parallel? A series and a parallel. So we have some in series and some in parallel. And this is why I say it's a more complicated circuit. So we need to remember our rules. Series, voltage is equal to V1 plus V2, and I'm just writing it down, plus V3. I is equal to I1, I1 equals I2 equals I3, and then in parallel, right, voltage is equal to V1 equals V2 equals V3, and I is equal to I1 plus I2 plus I3, right? So those are my different voltages there. Okay, so then let's just go in and measure. I have our electrons coming out, they're coming out, and they're going past this point right here, right? Maybe we can start the other way. Oops, sorry. So electrons are coming out, they're coming out, and then they're splitting. They're splitting and going this way, and they're splitting and going this way, right? After they split, they go all the way down, they come back here, they come back here, and they merge again here. They merge into 20 amps. Then they all travel back to this battery at the original amount. So I know that the amount of current here, because it's in series with the battery, because they are going back to the battery and they're in series, there's no different paths, is going to be the same. So I know that I3 is going to equal I total because this battery is in series with the ammeter. So that means my total is going to be 20A because it's in series, and that means that the current is staying constant. Okay? I now also know that since the total current is 20 amps, when I come down here, there's 20 amps of electrons, and then half of them go this way and half of them go this way. So I know that my I1 is going to be 10 amps and my I2 is going to be 10 amps because I'm taking the 20 current and dividing it by 2. Right? So I'm done my current. Voltage, like I said, a little bit more complicated. I know that my entire voltage, and I'm just going to change this so that you can see it in the different colors. So my total voltage here is 20 volts, right? As I go down across this, my voltage is going to get used up. Sorry, I'm just going to go this way. My voltage is going to get used up here first. So I'm going to use the voltage at the amp meter first. Right? And then it's going to go, and whatever's left over from there is going to go into here and go into here. Right? So that's what's going to happen. So, in order to do this, this is actually a mistake on my end. You needed to know how much volts this ammeter uses, and I'm going to say it uses 2 volts. So 2 volts. Right? So if it uses 2 volts, that means that my 20 is going to automatically lose 2 volts, so I'm only left with 18 volts here. I'm only left with 18 volts here. That 18 volts needs to split down going this way, and it needs to split down going this way, which means that my voltage here will be 9 volts, right? And my voltage, oops, sorry, I made a mistake. My bad. So we're going to pretend that this ammeter doesn't use any voltage. We're just going to pretend like it doesn't use any. So it's going to come down here, the voltage is still going to be 20, and it's going to go down this way, and it's going to go down this way. So that means at voltage 1, right, it's the only one there, so it's going to consume all the volts, right? So it's going to take, the volts are going to go down here. In that situation, because it's in parallel with the battery, the voltage will stay the same. So it's going to be 20. So I'm going to take 20 volts of energy straight from here. I'm going to go straight down, and it's going to split into this 20 volts of energy. Because it's getting half of the electrons, right? And the electrons have the same amount of energy. So as I go down here, my high-powered electrons with 20 volts of electricity are coming through, and then half of them are going to go here, but they all are carrying that 20 volts of electricity, or of energy. So that one's just going to get 20 volts. Now, unfortunately, the electrons that took this path didn't realize that they would have to go past 2 loads. Since they have to go past 2 loads, they're still coming in with 20 volts. But the first one, the first load, this light bulb here, is going to use some amount of voltage, right? And then this is going to use some amount of voltage. And then that both voltages are going to equal 20 volts because that's how much goes across this entire bottom, right? Because they're connected in series, they're going to use 10 volts each, right? Because at the bottom of that table, you need to split the voltage because when they're going across, right, the electrons are going to come and they're going to be like, okay, we have to use 2, so we got to use our energy carefully. We have 20 volts of energy. Let's use 10 volts here, and let's use 10 volts here. And at the end of this, we will have used altogether 20 volts, which is how much we had to start with. Okay? So that's why that is like that. And that's how you would solve that problem. It's a little bit more complicated because you have both in series and out of series. So I personally don't like using the equations. I just like to think of it logistically. Okay? Alrighty then. Okay. Try doing this one by yourself and then just come back and watch the video if you have questions. Okay, so then you have this 10-volt battery, right? Let's start off with putting in what we know. We know that V2 is 4V. We know that I3 is 10A. We know that V3 is also 2 volts. So this is also 2 volts here. Okay, so I like to look at this and be like, okay, I have a series and a parallel circuit, so let's just try to start doing some sort of analysis. And this is a lot of thinking. So I have 10 volts of battery. My electrons are leaving super high energy. They come through here and I have to use 2 volts. So now all of a sudden, at the end of this, right, because I'm minus 10 minus 2 volts, I'm left with 8 volts of energy to use. 8 volts of energy to use. 8 of those volts are going to go down this pathway. 8 of those volts are going to go down this pathway because they're all super high energy still. And 8 of those volts are going to go down this pathway. So I have 8 volts to use here, right? I have 8 volts to use here and 8 volts to use here. Here, I only have one load. So that one load is going to take up all my energy. So I'm going to use 8 volts at V5. So I'm going to go put that in, 8 volts. I'm going to come back up. This one, same. I used 8 volts. All my electrons are going to use all their energy in one space. So it's going to be also 8 volts. Right? Then I know that my first thing here is going to use 4 volts of energy. So I'm going to have 8 volts coming in. It's going to use 4 volts of energy. Now my electrons only have 4 more volts to give, and they're going to use them here. So then I have 4 volts of energy. And then we're all going to come back together, and they're going to be dead, and they're going to recharge and go again. Okay, so that is how we're going to find the voltage. Now I'm going to erase this, and I'm going to move on to finding the amps. Now, I'm going to do this in, maybe I'll do it in a more pink pen. Let's do it in this bright pink pen. Okay, so I have my electrons coming out. They're coming out, right? They're coming out. They all pass through this load. So that means that the current here is going to be the same as the current here because they're in series of each other. So I'm going to have 10 amps and 10 amps. So that means that my total amps are 10 because they're the same because they didn't split the pathway. The amount here is the same as the amount there. Now I have a pathway split. Now my 10 amps are going to split off into 3 different pathways because now they're in parallel, right? So I got to take my 10 amps. I have 3 separate pathways. So I got to do, okay, I have 10 amps in total, right? So I had 10 students leave the classroom and there was 3 different ways that they could go. So I have to do 10 divided by 3, right? 10 divided by 3 is equal to 3.33 amps here, 3.33 amps here, 3.33 amps here. So as it goes through the first load, 3.33 amps will follow through there. 3.33 amps will follow through the first one. They'll join back up here and then come back to the battery. Right? So load 1 will have 3.33 amps. Right? Load 2 will come 3.33, or load 4, sorry. 3.33, gonna join back up and give me 3.33 there. And the last one will also have 3.33. And we already knew what 3 over here was, and that was 10 amps. And I didn't have a 5, so just ignore this. Okay, and that's how you would solve that one. And I know after you see me solve it, it makes sense. So it's just a lot of using logic and being like, okay, what am I actually trying to find here? What's actually happening in the circuit?